All right, we're back. We're on page 4 of notes 12 of Calc AB, and we're talking about definite integrals, and we talked a little about displacement. We talked about, I don't know, signed area, like a lot of stuff. So let's see if we do, this looks like it's a pretty typical type of problem, but then the questions aren't really that typical because usually they're a little more in-depth, but we'll see. Problem. A particle located at x equals 5 feet when t equals 0 seconds. So x equals 5 feet when t equals 0. That's like an ordered pair on the position function. The position is 5 when t is equal to 0. Ordered pair on position. Moves along the x-axis with velocity shown in the graph below. So we are given the velocity. So this is a graph of v of t. And then, I don't know. So if this is going to be in seconds, then this will have to be in, if your position is in feet, and your time is in seconds, this velocity should be feet per second. Okay, so I don't know how I'm abbreviating that these days. Okay, so there we go. So if x of t is position function and v of t is the velocity function, what's the relationship between x of t and v of t? Well, v of t is equal to x prime of t. It's the rate of change of position. Velocity is the rate of change of position. Describe what the particle is doing at t equals 4 seconds. So t equals 4 is, that's like right here. Okay, so the velocity is positive because it's above the horizontal axis. The acceleration is actually 0, right? Because acceleration is the rate of change of velocity. So acceleration is the derivative of velocity, which means if velocity is horizontal, the rate of change of velocity is 0. So this thing I'm going to say is moving to the right because it's on the x-axis at 4 feet per second. Acceleration is 0, so I'm going to say with constant speed. So describe what it's doing at t equals 4. It's moving right at 4 feet per second. Constant speed because a of 4, so let's say a of t equals v prime of t. A of 4 is equal to 0. So constant speed has no acceleration. And some of this kind of harkens back to some notes that we did earlier in the year on velocity, position, velocity, acceleration. Find those notes. I don't know which notes they are, like maybe 4, something like that, and look those over if you need to. It's so dark in here right now. Don't know why. Describe what the particle is doing at t equals 8 seconds. So t equals 8 seconds is going to be like here. So your velocity is 2. You're above. So you have positive velocity, but your acceleration, what's the slope here? We're going down 4 over 4. So is -1. So you have a positive velocity and a negative acceleration. So you're moving to the right, but your speed is decreasing. So let's try to write that up. So moving right because your velocity is 2 feet per second. Speed is decreasing. And the reason your speed is decreasing is that a of 8 is -1, and then v of 8 and a of 8 have opposite signs. So anytime you have opposite signs on velocity and acceleration, speed is going to be decreasing. So opposite signs. Okay, I think that's a good answer. T equals 11. Okay, t equals 11. We're here. So your velocity is negative and your acceleration is negative. So same acceleration, still -1. Now your velocity is -1. So let's see. I guess I should put units on this acceleration here in the previous one. So let me just slide this over a little. So that was in it's feet per second and then per second. So you could say feet per second squared, or you could say feet per second, which I think is actually easier to interpret. So here we said you're moving to the left because v of 11 is -1, which let me write that out actually. Because v of 11 equals -1, which is less than 0. Your speed, this is a better answer than the previous ones that I've given, because I think I'm justifying it better. I mean, I put the velocity, but I didn't like that. But this time I forgot the units, so give and take. All right, so your speed is increasing because a of 11 is -1 feet per second squared, and therefore v of 11 and a of 11 have the same sign. And anytime you have the same sign, your speed is going to be increasing. Okay, so what are the units along the horizontal and vertical axes of the graph? I mean, I think we already labeled those. So the vertical is feet per second and horizontal is seconds. So we can just like straight up write that down. So horizontal is in seconds and vertical is in feet per second. I hope I'm doing those right. What units result from multiplying your previous answers together? I mean, if you do feet per second times seconds, it gives you feet, which makes sense because it's going to be displacement. Like we already kind of know that. Find the distance traveled by the particle. So distance traveled is different, right? Distance traveled, we need to account for our negatives as positives. So if we are looking at our graph, so what you're really doing when you're finding distance traveled, let me mark this down in some important color. Distance traveled is actually the integral from a to b of the absolute value of v of t dt, right? Think about what we do. We find each of our like displacements on each interval and we take the absolute value of them and we add those up. So it's actually the integral of the absolute value of v of t dt. So in this case, if I want to go from 3 to 6, well, what the heck, distance and, okay, so I mean, there's nothing really to be done there. 3 to 6, 3 is here, and then 6 is here. So your distance is just 3 by 4, it's just 12. I was expecting some of this action, you know, where you had to like reflect it or whatever. Not the case. But we can write it correctly. Distance traveled. So I'm going to say it's the integral from 3 to 6 of the absolute value of v of t dt. So put it in. Even if you don't need it, put it in. And that's going to be 3 times 4 is 12 feet. So distance traveled is in feet. In this case, displacement would be in feet. Find a time interval, should say, here on which the displacement is 0. So a time interval on which displacement is 0. So we need some canceling, right? So 8, if we go this way, you can see that we're gonna have areas that cancel each other out. So you could definitely say from 8 to 12. So I'm gonna do that. But I think I'm looking for like a good color. So if I go from 8 to 12, it's kind of odd about 10. So the area that we accumulate here is going to cancel with the area that we accumulate here. So we'll just get 0 if we go from 8 to 12. You can actually do like a weirder thing. So I'm going to say 8 to 12 because the integral from 8 to 12 of v of t dt is equal to 0. That's fine. I think that you could actually say, let's try this. This is a fancy pants answer. I'm going to say 10 minus k to 10 plus k for v of t dt, where, so this equals 0 for k, an element of, what am I doing? 0 to 2. Think that one through. So as long as k is between 0 and 2, the integral from 10 minus k to 10 plus k of v of t dt is going to be 0. So what does that mean? That means when k is equal to 0, you get 10 to 10, which definitely gives you 0. When k is 1, you get 9 to 11, which definitely gives you 0. When k is 2, you get 8 to 12, which gives you 0. And everything in between will also give you 0 because you keep that symmetry around 10 and you stay within 2 units. So it's going to work. That's extra. You don't need that, but find the distance traveled on the time interval you found above. So we're definitely going to do this one, I think. So that's going to be the integral from 8 to 12 of the absolute value of v of t dt, which, so you have a lot of options there. You can actually just do 8 to 10 and then double it, which I might recommend because the absolute value is just going to go it's going to give you kind of this graph. So if I go from 8 to 10, that's half of 4, so 2, and then double it gives me 4. So I get 4. So that's going to be 4 feet. So that's our distance traveled. Our displacement is 0, but our distance traveled is 4. We could probably work it out in general for the like extra answer. I don't think I'm going to do that right now. I don't know. All right, fill in the table below of the particle's position over time. So the sort of interesting thing is we started off with this piece of information that we have not used, right? We were told that at t equals 0, x is 5. We haven't used that yet, but now we need it because that's a position. So when t is 0, x is 5. So then to figure out where you are at 3, you've got to do where you started plus your displacement, which will just be the integral from 0 to 3 of v of t dt, right? That's how you figure out where you are. It's like, what's your displacement? Maybe your displacement is negative 18. Okay, but where did you start? Did you start at 0, in which case you're now at negative 18? Did you start at 18, in which case you're now at 0? The starting point matters, right? So it's where you started plus your displacement. So let's see what the integral from 0 to 3 is. I'm going to say that this is 6, and then this is half of 6. So overall, you get 6 plus 3, so you get 9. So that's going to be 5 plus 9 is 14. Okay, so now if I want to know where I'm at 6, I have 2 options. I could say it's where I started plus the displacement. So 0 to 6, v of t dt. Or I could say it's where I was at 3 plus the displacement. So 3 to 6, v of t dt. Usually when you're filling in these tables, you want to just keep going from left to right. So you want to basically do this one because you don't want to have to go back and then like accumulate everything. You want to just keep moving. So I need 3 to 6 v of t dt. So 3 to 6 we already did. Oops. It's from 3 to 6. So that's 3 times 4, so 12, which we found, but I was just trying to confirm. So that's going to be 14 plus 12 is 26. Okay, so for 10, we have 3 options. We could go 5 plus 0 to 10 of v of t dt. We could go 14 plus 3 to 10 of v of t dt. Or we could go 26 plus 6 to 10 of v of t dt. And you can probably guess which one is the best. This is the best because you just want to keep moving. So 6 to 10 gives us, so from 6 to 10, that's 4. That's 4, so 16, but you get half. So that's going to be 8. So we'll add 8 here to get us to 34. Oh, what? I don't know what happened there. That gets us to 34. And then 12, we have 4 options. I'm going to write them down because I think it's important. So we could do 5 plus the integral from 0 to 12 of v of t dt. That's like a bad choice. We could do 14 plus the integral from 3 to 12 of v of t dt. That's slightly worse. That's a slightly better but still terrible choice. We could do 26 plus the integral from 6 to 12. I don't know why we would do any of these. Or we could just do 34 plus the integral from 12 to whatever we're going to. Nope, 10 to 12. 10 to 12 VOTDT. That's the one we're going to do. So let's find 10 to 12. 10 to 12 is half of -4, so it's -2. And so 34 plus -2 is 32. So one thing that I think helps here is if we look at this graph, so this is the graph of velocity. The velocity changes from positive to negative at 10. We should get a relative maximum at 10. And if you look at our table, it does sort of indicate a maximum. Like we got up to 34 and then we decreased again. It's not perfect because the table doesn't have a lot of values in it, but it's interesting. That's another connection that we should try to be making, right? Like, does this thing ever get up to x equals 35? It does not, because there's a maximum at 10, and we know where it is at 0, we know where it is at 12. Candidates test. You never get there. The absolute maximum is 34 because it either happens at an endpoint or a critical point. And if 34 is the absolute maximum, you never got to 35. So you can answer a lot of weird questions. Did we ever get to 0? We did not, because 0, 12, and 10, that's the endpoints, the critical point. You never got to 0 because 5 is the absolute minimum. So there's a lot of stuff you can learn by doing this. And I don't know, I'm gonna cut it here. These are all the answers that we got. Good page, a lot of important stuff here. So I will see you in the next video for more stuff. So see you there.